Assalamualaikum. Welcome to our project videos for computer organization and architecture. For this project, we create a 4-bit register and a 4-bit logic unit. The 4-bit register stores 4-bit input data, control when data is updated using the clock, and can be cleared to reset everything to 0. It works like a small memory that temporarily hold data in the CPU. Meanwhile, the 4-bit logic unit take 2 4-bit input and perform logical operation like AND, OR, XOR, and NOT. It help the CPU make logical decision.
Okay, this is the truth table for the circuit. The Boolean expression for this circuit is F equals to NOT D0 and D1 or D2 and D3. So basically, we have 4 input D0, D1, D2 and D3 and 1 output F. The output will only be 1 when one of these two conditions happen. First, when D0 is 0 and D1 is 1 because of the term not D0 and D1. Or when D2 and D3 are both 1 because of the term D2 and D3. For all other input combination, the output F will be 0. If you look at the table, you can see that every time D0 is 0 and D1 is 1, F becomes 1. And also, when both D2 and D3 are 1, the output is also 1. So from this truth table, we can say that the circuit detects two specific input conditions and give output 1 only when the logic expression is true. This is the circuit that we built in Logisim evolution. It has 4 input switches, D0, D1, D2 and D3, and it produces 1 output through a D flip-flop. The logic part of this circuit uses a NOT gate, 2 AND gate, and 1 OR gate. Here's how it works. First, the input D0 goes through a NOT gate, so it becomes NOT D0. Then NOT D0 and D1 are connected to the first AND gate, which gives the output of NOT D0 and D1. Next, the input D2 and D3 are connected to the second AND gate, producing D2 and D3. After that, both outputs from the AND gates go into the OR gate, which combine them together. So the logic equation for this circuit is F equals to NOT D0 and D1 or D2 and D3. Finally, the output from the OR gate goes into the D flip-flop. The flip-flop is used to store the output value and it only updates when the clock signal is triggered. This makes the circuit a sequential circuit, meaning the output depends not just on the current input, but also on the previous state stored in the flip-flop. In simple words, the circuit checks for two conditions, when D0 is 0 and D1 is 1, or when D2 and D3 are both 1, and then store the result as the output. This type of circuit can actually be found in real CPU component. The combination of logic gates and flip-flop is very common inside a processor. For example, the logic gates are used in the control unit to make a decision based on the input condition, just like how the circuit checks the value of D0, D1, D2, and D3 to decide the output. The flip-flop part is used for data storage or state holding. In a CPU, flip-flop are used to store bits temporarily, like int register, counters, or status flag. So this simple circuit represents how the CPU processes logic and stores result. It shows the basic idea of how computer perform logical operation and remember the output for the next step.
And I will explain briefly about this 4-bit logic unit or ALU slice, focusing on the truth table. This ALU slice has 2 data input, A and B, and 2 control inputs, C0 and C1. This control signal decides which logic operation the circuit performs, and the output is F. From the truth table, we can see 4 main functions. When C0 equal to 0 and C1 equal to 0, the circuit performs and output F is 1 only when both A and B are 1. When C0 equal to 0 and C1 equal to 1, it's performed OR. F is only 1 when either A or B is 1. When C0 equal to 1 and C1 equal to 0, it's performed XOR. F is 1 only when A and B are different. And when C0 equal to 1 and C1 equal to 1, it's performed not A, which means the output is the opposite of A. So from this truth table, we can understand that C0 and C1 add a selector that chooses which logic function the ALU will do. This is how one small circuit can perform multiple logical operations.
Right now, I will explain about the Logisim circuit for the 4-bit logic unit. Firstly, we can see the 1-bit ALU on the left. This part will perform one logic operation for a single bit only. It uses logic gates like AND, OR, XOR, and NOT. The output, which is F, depends on the control inputs C0 and C1. Next, on the right side, we have the 4-bit ALU. It's built by the connecting 4 1-bit ALU slices together. Each slice processes 1 bit from the inputs A and B, and all of them share the same control signals and constant input. That means all 4 bits perform the same logic operation at the same time. I'm going to explain about the application in real CPU component. In a real CPU, the ALU has 2 main jobs. Firstly, it does the arithmetic operation like adding, subtracting, multiplying, and dividing. This helps the CPU to run instructions such as adding and subtraction. Secondly, it performs logical operations like AND, OR, NOT, and XOR, which help the CPU to make decisions, test conditions, and control the program flow. These 2 functions let the CPU process data and run the program correctly.
Overall, this project really helped us understand how CPU components such as a register and logic unit work in real system. Thank you for watching our presentation. See you next time.